Hi everybody. So some of you have noticed that I had a little bit of a glitch on this week's Canvas page. And so what I'm going to do is kind of split the difference. There was another step to the home range analysis lab for the coyotes. And so what I'm going to do, because I messed it up, is give you all that information but not require it. I want you to get everything you can out of this class, but it's not really fair to dump that on you without giving you a heads up. So now we're on the properly edited tab for this week, and if you scroll down to the to-do section here, this is not required, but I've got some new instructions for you here and then information about the data. There's still a link to submitting the first part of this lab, so you do still have 2 weeks to do that. This is the one with all the Python script in it. It's calculating the home ranges of the coyotes. So you've got 2 weeks. Tonight, Monday the 18th of March, the data update is due. Keep it very simple. I just want to make sure everyone's kind of moving forward, and data can usually be the biggest trip up. So if you're familiar with your data and you know you have what you need, just keep it really simple. And then if you want to get this use versus availability section done and get some feedback on it, absolutely, I created a submission page for it, so you can do that. I just want to walk you through really quickly what this is about. So this is ArcMap here. You should be familiar with that. And the idea is we've calculated these home ranges. And so what we want to figure out in this use versus availability lab is the difference or the preference ratio that we can calculate between what's available to the coyotes versus what they're actually using. And that way we can maybe figure out if there are certain land cover types or habitat types that they are overutilizing or underutilizing, to better understand this specific animal's behavior. But again, remember, this can be anything. This could be fish pit tags, it can be people driving around in cars, it can be, people hiking in national parks. So in this map, I've got all of the coyote points. Remember, you don't want to use the individual coyotes at this point. Go back to the original data set. This is the calculated 95% general area, so that polygon would be really helpful. And then the instructions show you how to go to the Landfire website and download the existing vegetation types. So that's what's in the background here. This data, remember, uses the value is nominal or categorical legend value that represents a vegetation type. So these aren't ranked numeric. You can't take averages of these or ranges of these to have them make sense. They're just a code that represents a land cover type. But this is the field that's going to be utilized in our analysis, the value field. 3001 equals Intermountain Basins sparsely vegetated systems, for example. Okay, so that's the black and white thing that's going on in the background here, the grays. And what I did is I just clipped so that I've got the general areas, the general land cover types for the whole population of coyotes. So that's what that is. And so now with this data, this is the clip data, I can go in and look at the counts of each one of these land cover types. I'm going to sort this descending, if I have some cooperation. So Intermountain Basins, mixed salt desert scrub, is the most dominant land cover type. Most of the cells, the count is how many cells are this unique value. So this is the most common land cover type that's available to the coyotes. So the question is, if we extracted the actual land cover type at each point location, would it also be the most utilized land cover type, if that makes sense? So you can see here that the most common ones are introduced upland grasslands, shrubland, greasewood flat, pinyon juniper woodland, more shrubland, barren, biennial foreland, roads. So this is the most common stuff that's available. What we want to do then is run the tool extract value to point. And what that's going to do is create a new point file that has a raster value field in it, like this. So this is the attribute table for all the points. And what we want to do is use these raster values. Now you're going to want to get rid of all of the points that aren't in that general range. And typically you'd get a bunch of null values in here because they don't have any value, but it's possible that I either extracted value on the original Landfire data set, but you're going to either want to use a select by location to just pull the points that are within this general, or when you do your extract value to points, just delete all the null values. It doesn't really matter which way you do it, as long as you don't want to account for these guys out here. We're just talking about the general home range. Okay, so raster value, you could use a pivot table in the instructions that I give you, because what we want to know is how many points are sitting on 3181, how many points are sitting on 3081, how many points are sitting on 3153, and get a count for these. And here's why. Here's what the rubric may look like. What I did is I went in and kind of extracted the top values for all of the available stuff, and that's what's here. So these are the land cover types. Here are the counts, and what I did is I summed the count. So I just selected these, and let me bring this down so you can see the top of the window here. It did an auto sum, and it just populates with how many. So this is the total cell count within that area, and then you would divide each one of these by the total to get the proportion of each land cover type to the whole. So this should sum up to 1, and it doesn't. I blew it somewhere. I probably didn't include a couple of really small land cover types. So if you're working with the whole data set, yours should sum to 1. But what this is saying is these are the different proportions. So a quarter of the available land cover is introduced annual grassland. Half of it is salt desert scrub. These may vary from your results, by the way. So these are the proportions, and you can see that I've got this great big number here. This is the biggest value, so these should make sense to you. Now, where we go from here is that if the coyotes didn't prefer anything over anything else, we would expect to find half of the points in salt desert scrub. And so what you can do is take the total number of points that you have, and you can get that from your coyote data. You know how many points you have in this data set, right? And from that, you can multiply it through and say, let's just say you have 900 or 850 points that you're working with. Well, 800 times 0.04, or half of 800, would be 400. And so you'd expect 400 of the coyotes to be on salt desert scrub because it makes up half of the territory, the general territory. And so you're going to multiply through your total number of coyote points and get your expected. Then, what's actually utilized? So I apparently had 859 coyotes that were sitting in my general home range. And so this is what I multiplied through here. You can see that it's D2 multiplied by probably F16. Yeah, so it's multiplying this by this to get what we'd expect to see. Then we have the used, and this is what you're going to get from your pivot table. So how many of the actual coyote points were sitting on value 3080 or 3297, and this is that count. So then the question is, how are these comparing? If we expect 35 to be sitting here, but it's actually 61, then we know that the coyotes are overutilizing or maybe preferring this land cover type. When we see that it's being used more than it's expected, it's a preference. When we see it being utilized less, like this one, introduced annual grassland, this is probably cheatgrass, it's being underutilized, and so this is not preferred land cover type. So the last thing I want to point out is that, well, you calculate this ratio, and so the preference ratio is just dividing these two. And then that's where you want to be careful. If you're expecting 35, but you're actually seeing 61 utilized, then that's an over preference. That's a preference, basically, an overutilization. And so those are going to be the values bigger than 1 if you divide it that way. You just need to keep track of this, but that's the classic way of doing it, where values greater than 1 are preferred land cover types, and values less than 1 are underutilized. Where you need to be a little bit careful is if you have an N of 3 or 4, you might end up with a solid value up here, but can you really say, if you've got 6 points out of almost 900, can you really say that that's a preference? Probably not. These are more solid where you have higher numbers. These guys, this guy. But here you've got yeah, boy, they don't seem to really care about this land cover type at all. Well, really with an N of 10 out of 900, that's not a very good or solid statement to make. So you can be pretty confident in these bigger numbers is, I guess, my point. So it's a very, very cool thing to be able to do. It's slick, it's easy, it's logical, and it's utilized all the time, not just for wildlife, but all sorts of different entities, four-legged or otherwise. So if you have any questions about that, let me know. And that's it. Thanks.